Welcome to my kcse revision channel, Teacher Marita, Tribal Sports High School. Kindly subscribe, click the notification bell such that you get notified once I upload a new video. Today we are looking at kcse revision, paper 2 chemistry question, and that is energy changes. And today we are looking at bond energies. In bond energies now, there are some of the calculations we want to do. For example, we have been given here calculate the enthalpy of formation of hydrogen chloride, given that the bond energy between hydrogen and hydrogen is positive 436 kilojoules per mole. Chlorine and chlorine is positive 246 kilojoules per mole. And then we have hydrogen and chlorine is negative 431 kilojoules per mole. Then we have this equation of reaction where we have the hydrogen gas combining with the chlorine gas, and then it forms 2 moles of hydrogen chloride gas. So you need to find the enthalpy of formation of hydrogen chloride. So first of all, there are 2 things you need to know. You calculate the bond breaking, and then you calculate the bond formation. So first of all, you start with bond breaking. So we have bond breaking, and in most cases, bond breaking, the heat energy is equals to P. This one is a positive. It is an endothermic reaction. So, and this one normally it involves on the reactants. So we have this hydrogen. So we can have hydrogen here. You have this is hydrogen, and then you link with another hydrogen. Plus now here we have chlorine. So we can have this is chlorine, then we have chlorine. So this is the bond breaking of hydrogen, and this is the bond breaking for chlorine. So here in hydrogen we have only one bond, and one bond of hydrogen is equivalent to 436 kilojoules per mole. Then we have in chlorine bond breaking we have only one bond, and this bond is equivalent to positive 246 kilojoules per mole. So here you just have positive 436 kilojoules plus now positive. So we plus this one as positive 246 kilojoules per mole, and that one is gives us it will give us the total energy needed for atomization. You add this and this one. So if you add the 2, this one will give us positive 678, in this case kilojoules. This is the total energy needed for atomization. So we have the atomization of hydrogen gas, then we have the atomization of chlorine gas. So the total energy needed here it is positive 678, and this is the bond breaking, and it is always an endothermic reaction. Then from there you calculate now the bond formation. So you can have again bond formation here. So you talk of bond formation, and the bond formation it is always an exothermic reaction, so it should repeat a negative. So in the bond formation now, it normally involves the product on this side, and now we have this one here. It is 2 moles of hydrogen chloride. So you will be having these 2. So you have these 2 here. Then we have the bond formation between hydrogen and chlorine. So we have this is hydrogen, and then we have chlorine. So the total number of bonds we have here, it is 1, and this one is equivalent to the negative 431, but we have 2 moles of this hydrogen chloride. So you take these 2 now times negative 431. So we have this is 431, and that one will be equivalent to negative 862, in this case kilojoules. So we have this is the bond formation. We have the bond formation here, which is an exothermic reaction, and then we have the bond breaking, which is an endothermic reaction. So to get the enthalpy for formation of hydrogen chloride, you just say it is bond breaking plus the bond formation. So, or you can say the total energy needed for atomization plus the energy required for a bond formation here. So, in short, you can say the heat for formation of this hydrogen chloride now is equivalent to, you will have this one as bond breaking. So you will be having bond breaking 10 plus the bond, in this case, bond formation. So what do we have in bond breaking? We have this one as a positive 678, in this case, kilojoule, plus now bond formation is negative 862 kilojoules per mole, and if you combine that one, it will give us negative 184. So this one is giving us negative 184 in this case kilojoule. Now this is not the end. We have 2 moles of hydrogen chloride, and we need the enthalpy formation of 1 mole of this hydrogen. So if 2 is equivalent to this one, so if 2 moles of this hydrogen chloride, 2 is equivalent to negative 184 in this case kilojoules. What about now 1 mole? So you will say this one 1 mole is just 1 times now negative 184 kilojoules. You divide this one by 2, and this one will give us negative 92. So we have this one as a negative 92. In this case, negative 92 kilojoules per mole. So we have this is negative 92 kilojoules per mole. So from here, you can conclude that the reaction is exothermic because of this negative. Can you conclude that one there? The reaction or the formation of exothermic. So we have, you can conclude that the heat energy required for the formation of this hydrogen chloride is just an exothermic reaction. We have another question here where we are finding now, calculate the enthalpy of formation of steam. The formation of steam is normally where we have hydrogen combining with oxygen, and therefore it forms steam. The energy required for the bond energy in hydrogen is positive 436. Oxygen and hydrogen is positive 464. And then we have oxygen, and oxygen is 497 kilojoules per mole. So we need to calculate the enthalpy of formation of steam. So you start with the first of all, we have the bond breaking. So we start with the bond breaking. So we have bond breaking. And in bond breaking, we have said that the energy must be a positive. It's an exothermic reaction there in that case. So in bond breaking, it is normally involving the reactants. So we have, this is a hydrogen. So we have 2 hydrogen. So we can have hydrogen, then we have hydrogen like this one here. Then plus we have oxygen. So the bond breaking for oxygen is this one here. So what can we have here? So we have only 1 bond between hydrogen, which is equivalent to positive 436, and then we have 2 moles of them. So we can multiply this by 2 in this case times 436, then plus for that one of oxygen, which is 497, and that one will be equivalent to a positive. So we have this as positive 1369 in this case kilojoules. That is the bond formation, or the total energy required for atomization of this hydrogen and oxygen, which is equivalent to positive 1369 kilojoules per mole. Then we have a bond formation. So we have again bond formation here. And the bond formation is always an exothermic. So we have this one as an exothermic. That one is an exothermic. The heat is normally released to the surrounding. So what do we have there? We have two, the two for these two, and then we have two hydrogens. So we can have this one here, hydrogen. Then we have, we have hydrogen, we have oxygen. We have oxygen here. Then we have an hydrogen, and then we have an hydrogen here. So the total number of bonds we have here, it is 1, 2. And one bond between hydrogen and oxygen is positive 464. So you take this one as is equivalent to be 2 times the number of bonds. The number of bonds here we have 1, 2. So times this one as 2, and again now times the bond for the energy for one bond, that is 464. So you have this is 464. So that one will be equivalent to 1856. So we have this one as 1856 in this case kilojoules. But remember, at this side here, in the bond formation, the station is always an exothermic, and therefore this value must be, we have this value as a negative. Then applying this information here, that the heat for the formation of this steam is equivalent to P, it is bond breaking in this case, plus bond formation. So what do we have? In bond breaking, we have positive 1369 in this case, kilojoules. Then plus, this one is a negative 1856 in this case, kilojoule per mole. So if you add that one, you can end up getting negative. This is giving us a negative 487. Negative 487 in this case, kilojoule per mole. Now we have here, we have 2 moles of steam. And here, these 2 moles of steam will produce negative 487. So what about now 1 mole? So from there you say that if 2 moles of that steam will just produce negative 487, in this case kilojoules. So 1 is equivalent to what? So it is 1 times negative 487. Then in this case you divide it by 2, and that one we get this one as 243.5, in this case kilojoules per mole. So what you can conclude from there, this one here is a negative. So you can conclude from here that the reaction is normally as an exothermic reaction, because this one is a negative. So what is the main important thing you need to understand? Bond formation, bond breaking is always an endothermic reaction. Bond formation is always an exothermic reaction. And the areas which is normally challenging candidates here is where we have, for example, we have this is 2 moles of steam. So what we have here is just 2 moles of steam, and we need the enthalpy formation of steam. So you divide it by 2 such that you can get the enthalpy for the formation of just 1 mole of steam. We have come to the end of our lesson. You kindly subscribe, follow my channel, you click the notification bell, you get notified once I upload a new video.